So far, the 3D scenes we were creating were only using a Canvas HTML element. But one of the main benefits of using Three.js and React 3 Fiber is to integrate it perfectly with DOM and HTML elements. There are two ways to do it. The simplest way is just to have the canvas as a background to your page and have your HTML elements on top of it, and then to connect the 3D scene to the HTML one by listening to mouse events or to scroll events. We will learn how to achieve this in the scroll and animation lessons. But another great solution to integrate HTML elements is to add them as if they were into your 3D scene directly. For this lesson, I imagine an online showroom with kitchen furnitures. On top of those 3D models provided by Quaternius on Polypizza, we will try to add additional information like the price and the name of the product. I chose this scenario because it really looks like a project you could have to build in your career. Before diving into the HTML, let's have a look at the code of the starter project. We have orbit controls that we learn together, environment that we will discover in the staging lesson, but to make it quick, it's what is responsible of the lighting of the scene. Then we have contact shadows that we also have seen together, and we have an experience where we will have all our furnitures. Our experience component is only iterating through scene items and is rendering items. Let's have a look at what scene items are. It's the name of a GLB model file, the position of the model, and its scale. And for the Dango here, it also contains the rotation. Then we have the item component, which is just loading our GLTF model and displaying it. Now, as we mentioned, we want to add the price and the title for each element. We will add those information into the scene items, then we will render them in the item component. So for Japanese door, let's name it Hemnes. Then we add the price, 300. We do the same for each object, namely Lengen. The price is 4,050. The chopping board, name Skogstad, and the price is 25. The fridge, and its price is 600. Table, 80. And then the Dango, we will just name it Dango because it's food and not a furniture, and 4. Now on each item we have its name and its price. We can go to the item component and try to add those information into it. Because we are inside our canvas, if you look at app.jsx, here our experience is inside canvas, we can't add directly HTML element like this, like adding a div. Let's remove it. To do that, we will use the HTML component from Dry library. As always, have a look at the documentation and different examples provided by it. What it does is it takes care for us of the position of the HTML element based on its 3D position, and it makes it appear like if it was really into the 3D scene. Let's add it simply into our item. We add the HTML component from Dry. Then we add our div. Class name will be label. Then inside, let's add the price. Label __ price. This is the block element modifier syntax I chose. We will use props.price, or better, we can just get the price by destructuring it here and also the name of the product. Then we do the same for the name, label name. We display the name and it doesn't require the $sign. Of course, because it generates HTML content, you can use any tag like P or H1 if you are concerned about the accessibility and also the SEO. Without styling, this is what we get. We have the price and the text display on the position of our elements here. Let's have a look at the inspector to see the generated HTML. We have the root div here with the containers and the canvas. But our HTML elements are outside this canvas. They are positioned like this. We have Lilegen. It's automatically using transform properties which are CSS properties, to make it appear as if it was into our 3D scene. But the reality is it's completely separated, and the transform property make it the magic happens. Thanks to Dry Library making all the difficult calculation for us. But so far it doesn't look so good, so let's add some CSS. You can use any CSS framework that you like. I'm a big fan of Tailwind, but I will just write raw CSS to make it the more generic possible. Our project should already contain an index.css. This is where we can add our CSS. Our container is .label. Then we also have label __ price and label __ name. Because it's not an HTML CSS course, I won't explain in detail each property. We are adding some padding to make spacing, the background color of our container. We add some border radius to soften the angles. We add a box shadow. We disable pointer events. This one is very important if you don't want to have conflict between your orbit controls and the label component. And then we center the text. For the price, we just make it bigger and bold. Then we set the font size for the name and its color to a gray. Let's add a custom font to make it look better. I would choose the Inter one. Go to it. Then you select the different size you want. I will choose regular. And we chose bold because we have some bold styling into our CSS. Then we can take the import one here and copy it. On top of our index.css, we need to add the import line. It's really important to be the first lines you have. Then we can define the main font for this project inside the body. We'll use font family, Inter, and sans serif if it's not loaded properly. Now it's already starting to look good with our label styled properly. We have a small issue. If we select the text, it's working. We don't want this. To make the text not selectable, we can add the noSelect class. I always find the CSS inside this Stack Overflow here, so you just have to copy all the different. It works on all major browsers. We can go into our index.css and add the noSelect class. Now, if we try, we can't select the text anymore. To make it look better, we will add some occlusion. It is the fact that when a label is behind a 3D object, it will be hidden as if it was really integrated into our 3D scene. With the HTML component, it's made very easy. We just have to add the occlude prop. But if we do it with the current position of our label, it's blinking and it's almost never appearing. This is because our labels are at the 0,0 position of our object, so they are conflicting with the object they are the label of. To prevent this, we will add an offset to the label to not make it inside the 3D mesh. So let's go again to send items, and we will add a label offset. I've already found the position, but as always, you can use the Leva or you can find it manually. Let's repeat for each object. You can see we put it on top of the object, on the side, and more closer to us. It's just a matter of taste. So you don't have to copy me exactly on this one. For the table, and finally, the Dango. Now we need to apply this position to the label. We go on the HTML. It has a position prop, like any Object 3D element. And we can say, here, we destructurate the label offset, and we place it here. Now you can see that each object has a different label position. And if we go behind or in front of it, it disappears and reappears when necessary. If we go behind, most of them disappear. But it is not very smooth. When it disappears, it's doing it immediately and it reappears immediately. We can fix it by adding some CSS. But first we need to know if our item is occluded or not. So we can use the onOcclude property and we will set a state. So we'll name it hidden and set hidden. It will be equal to useState of false. And onOcclude, we can directly pass the setHidden function because onOcclude has a visible boolean. So it will either call it with true or false. Now we can apply a modifier class when the element is hidden or not. We can use this and use a back quote to add some conditional classes inside. If it is hidden, then we will display label -- hidden. So it's a modifier in block element modifier syntax Otherwise, we just do nothing. Now let's add it into the CSS. Let's go to the label. We will add a transition because we want to impact the opacity and make it smooth. For the opacity, we will use 0.42 seconds. And for the transform, we will use 0.2 seconds. Now, if our label is hidden, we will make it disappear with opacity of 0, and we will scale it down with transform scale 0.42. Of course, use your preferred value. Now, if we try again, when an element disappears, it smoothly fades out and scale down, then it reappears nicely. Currently, our HTML elements have a billboard effect, which means the text is always facing us. Maybe it's what you want. Maybe for this project, it is the best. But in some cases, you want it to be more integrated into the 3D scene. For those use cases, in the HTML component, you can add the transform property. Now it has a real 3D position and rotation, but it appears very big. To fix it, we can decrease the scale property. Now our label have nice sizing, and you can see that they are not following our camera position, but are always facing the same direction. The use of occlude and transform property is really up to your choices and to your projects. The more you practice, the more you will be used to place HTML elements, and the more you will develop your sense of design.